Yet another way of counting the way events can occur is called combinations, and it's related very closely to permutations, which we've covered. So permutations and combinations go hand in hand. The big difference between the two is that with combinations, order is not important, but with permutations, order is important. So let's just firstly revise a little bit about permutations. The rule for calculating the number of ways you can choose R objects from N objects is N factorial over N minus R factorial. And if we look at an example of how many three-letter words, and don't forget a word doesn't mean it occurs in the dictionary, it's just a combination of three letters in this case. How many three-letter words can be made from the letters M, A, T and H? So we've got four letters, so how many words, three-letter words can we make from those four letters? Now with words, MAT is a different word to a TAM, so for three-letter words and so on. So order is important, so it's not a combination. Combinations I'll talk about in a little minute, but it's a permutation. Permutation order is important. And if we were to calculate it, we use the formula NPR, so it would be 4P3 is 4 factorial. This number here goes up the top, and then it's 4 minus 3 factorial at the bottom. 4 factorial, 1 factorial on the bottom, 1 factorial is just 1. But 4 factorial are all the factors starting at that number all the way down to 1. 4 times 3 times 2 times 1. We really don't need to write that, but just for to make it clear what we're talking about here. There's a factorial 4, and 4 3s are 12, 2 times 24. So there can be 24 three-letter words that can be made from those four letters. And to explain the difference between a permutation and combination, it'd probably be worthwhile writing those 24 combinations out. So here they are, the 24 different words that you could make. So if we just chose the first three letters, M-A-T, there are these on this top row here are all three-letter words that can be made from MAT, all the different combinations that can be made there. So we've got MAT, MTA, ATM, AMT, TAM and TMA. And then we choose another, we leave the A out, we go MTH, and there are 6 of those, and so on. So if you add all those up, there are our 24 words that we can get. Okay, so the next question is to answer the question on combinations. So how many ways can I choose three letters from 4 where order is not important? This is what we would call a combination. So from above here you can see that the number of all of these, if order is not important, all of those would be the same combination. MAT, MTA are just using the 3. So if order is not important, those all count for 1. So we've got 1, 2, 3, 4. So there'll be 4 ways. And we need a way to actually calculate these. And the number of ways would be equal to all of this, which is 4p3, divided by, if you are choosing 3 letters, we've got to reduce this by a factor of 3 factorial, because 3 factorial is the number of different ways you can organise each combination of 3 letters. So here you've chosen the letters MAT. There are 6 ways, in other words 3 factorial ways that you can organise those. There are 3 factorial ways you can organise those 3 letters, M, T and H. There are 3 ways of putting the first letter, 2 the second and 1 the third. So there are 6 ways that you can organise those. There are 6 ways. So if we divide this by 3 factorial, 4p3 is 24, which we've worked out above, and 3 factorial is 3 times 2, which gives us our 4 ways above here. So let's develop that into a formula for converting permutations into combinations. So we use the letter C for combination, we use the letter P for permutation. So we've just set up here that NCR, to generalise now, would be NPR, this number and this number are the same, over R factorial. Now we've already, from the definition way up above up here, that NPR is equal to N factorial over N minus R factorial. So instead of this NPR, we can put N factorial over N minus R factorial, all over R factorial. A little bit of algebra here to knock this into shape, and we get N factorial over R factorial outside of N minus R factorial. So that's the definition of NCR. NCR is N factorial over R factorial times N minus R factorial, and we get that by using the NPR over R factorial. Now some properties. NCN is exactly the same. So this is the number of ways you can organise, or you can arrange n objects from n objects where order is not important, and that's the same as NC0, and that's equal to 1. You're going to take n objects from n objects and order is not going to be important. There's only one way you can do that. And another property is NCR equals NC n minus R. Alright, I give those with no proof at this stage, but it will come in handy with doing calculations.